Hello and welcome to this online tech talk where we will discuss how AWS services can be practically applied to address the intelligent document processing needs that many of our customers, particularly those in lending and insurance verticals, have. My name is Rahul Gupta and I'm a product management leader within the AWS machine learning organization. And I'm joined by my colleague Sonali Sahu, who's a solution architects leader. Before we dive in, let's quickly review the outline for this talk. So I will start by giving a brief overview of Intelligent Document Processing, or IDP, at AWS. And then I will walk through our first example use case, where we will take an in-depth look at how to apply our services to the lending use case involving the end-to-end processing of mortgage application documents. I will then turn it over to my colleague Sonali, who will walk through an insurance IDP use case example covering claims adjudication. She will then briefly cover some resources that can help you get started on your AWS IDP journey, and we will then open up for Q&A. So with that, let's jump right in. So documents are everywhere in business, and documents have famously been called the middleware of many business processes in several industries, such as the ones listed on the slide. Some of these documents may be industry specific. So for example, claims forms that are regularly processed by insurance payers, mortgage applications processed by lenders, or even pipeline pressure test records processed by oil and gas companies, while other documents such as invoices, receipts, tax forms, identity documents tend to be ubiquitous across multiple industries. In fact, it is estimated that 80% of data within organizations is what we call unstructured data or even dark data, which is locked up inside text, emails, PDFs, and scanned documents that organizations are not able to tap into, or at least struggle to do this at scale, which is clearly a missed opportunity. So why do organizations struggle with document processing? When we talk to customers, they tell us it is because the traditional ways of processing documents are increasingly falling short of customer expectations because of the exponential proliferation of data, as well as the ever-increasing expectation of customers for faster service times, along with internal pressures to constantly reduce and right-size operating costs. For example, if we take the case of legacy OCR, customers tell us that the accuracy of these systems is not sufficient to meet their bar or give them enough confidence, which means that most documents still have to be reviewed by humans reviews, which, as we know, is time-consuming, tedious, expensive, and difficult to scale. Even in instances where customers have invested in building templates or other rules-based engines to augment OCR, results have been subpar because document styles, formats, and versions tend to change, which limits any gains from automation and reduces the efficiency that customers are able to drive with these legacy approaches. It's for these reasons that organizations have increasingly started turning towards intelligent document processing from AWS that leverages state-of-the-art artificial intelligence and machine learning technologies to increase the efficiency of their document-intensive business processes, improve worker satisfaction, and delight customers. So with that, we'll now take a closer look at IDP. So what is IDP? IDP is simply the application of artificial intelligence to transform documents into structured, useful data. As we will see throughout the presentation, AWS offers the broadest and deepest set of capabilities to serve the end-to-end IDP needs of customers, which comes with the following benefits. First and foremost, our services are built to be secure from the ground up with end-to-end encryption, privacy controls, region and/or optional network-level isolation, SLA-backed resiliency, and more so that customers can onboard with confidence. In addition, our services are compliant out of the box with several regional and global mandates such as PCI DSS, HIPAA, FedRAMP, and others depending on the industry and geography. Second, customers just need to do simple API integrations with our services, and they do not need to acquire any in-house machine learning expertise such as ML engineers or scientists, as AWS does all of the heavy lifting on the customer's behalf. Third, we offer convenient pay-as-you-go pricing, and customers only pay for what they use. There are no complex licensing terms or upfront commitments that many other vendors require. Fourth, AWS also offers unmatched ability to scale up or down as your demand grows or shrinks, which combined with our pay-as-you-go pricing model gives customers unmatched operational flexibility as their business needs evolve. Moreover, with AWS IDP services, customers can accelerate the time to value as there's no machine learning models to train, OCR templates to build, or manage, or no infrastructure that needs to be maintained because our services are fully managed. And then using our services, we go well beyond what legacy OCR solutions are able to offer, especially through the power of AI ML, where we're able to not just read, but actually understand and convert that dark data from documents into structured, useful information with unmatched accuracy and flexibility. Now let's talk a little bit about our key customers and use cases. Starting with financial services, a very popular use case we see is within lending, which is made up of mortgage lenders that serve the trillion-dollar mortgage industry, processing millions of loan applications annually. Each application, in turn, can encapsulate a variety of documents. These could be pay stubs, tax returns, W-2 forms, identity documents, employment verification, which means that in aggregate, we're really talking about billions of pages of documentation, which our services are able to routinely handle. In healthcare, we see customers using our services for use cases such as claims processing, which could include member enrollment, grievances and appeals processing, clinical records, doctor's notes, authorization forms, you name it. We're also starting to see demand across the board from both commercial and public sector customers who are interested in modernizing their business processes, as well as customers in just about every vertical conceivable. So these include verticals like energy, where customers are using our services for processing oil and gas pipeline safety records, retail and logistics for invoices, receipts, and bill of materials, legal, where customers are using our services for analyzing contracts, licenses, warranties, and many more. Here's a sampling of some of the major customers using our services. This is by no means an exhaustive list and only represents a small fraction of our overall customer base that is publicly referenceable. But as you can see, we have customers who are leaders in their respective verticals spanning financial services, lending, insurance, healthcare, manufacturing, automotive, energy, and technology from around the globe that are well represented here. With that broad overview, we will now dive deeper into our first of two focus use cases for this talk, starting with lending and mortgages. Let's start by reviewing what a typical mortgage document processing pipeline looks like, and then work backwards from what our customers are trying to accomplish. So starting with data capture, customers tell us that they get millions of loan applications representing billions of pages of information as part of their loan origination systems from applicants. A single loan application can be 100 to 500 pages long, and so the next logical step in the workflow is classifying and then segregating these documents so that appropriate document-specific business rules can be applied. Therefore, the data then actually needs to be extracted from these scanned documents. And this is not an easy problem, given that the data could be represented in many different ways. For example, the text could be printed or handwritten. It could be represented in key value pairs on forms or as rows and columns in a table. Further, what makes it even more challenging is that a lot of document types, such as invoices, receipts, identity documents, pay stubs, don't even have preset or predetermined layouts. So the solution needs to be intelligent enough to extract information across the different variations. Now, even if customers have extracted all this information, they typically want to augment or enrich this information. This could be, for example, with internal knowledge graphs, or they may want to, for example, detect and redact personally identifiable information, or PII, in case documents need to be routed to human reviewers. Speaking of human reviewers, while the goal of IDP is to reduce reliance on human reviews through automation, humans can still play a vital role in the process, especially when it comes to validating machine output where ML model generated confidence scores may fall below a customer's threshold, or if secondary validation is needed for high value data within forms. So for example, if you want to validate net income on a pay stub. We see that customers may even apply additional validation checks here, for example, ensuring that the name of the applicant on a driver's license document matches the name on the loan application document prior to actually making the business decision. Now, while this may sound relatively straightforward, customers tell us that in practice it is anything but, and they face challenges with legacy document processing approaches in just about every step of the way. Let's look at a few just to make this real. For example, in the data capture stage, not only is it critical to ensure security and integrity of data, but it's rarely the case that a document that is scanned, for example, is pristinely presented. Oftentimes, customers tell us there could be scanning defects, such as presence of dirt, distortion if you're dealing with folded or crumpled documents, rotated text, and other challenges which makes data capture challenging. Within classification, while standardized forms may be relatively easier to classify because they have more predictable layouts, documents such as invoices, receipts, identity documents, bank statements are a whole different ballgame because they don't follow any preset layout, which again creates complications in classification. Within extraction, we already talked about how challenges in data representation can present complications, but there can also be complications related to nested or hierarchical data representation of structures, as well as variation in the field names itself. What do I mean by that? So take, for example, the key name Social Security. That itself can be presented as SSN, SSN number, or in about 20 to 30 different ways. And customers tell us that today, they typically end up writing normalization rules to account for these. Within enrichment, customers tell us they want an easy but very reliable and accurate way to identify and redact PII identities so as to remain compliant prior to sharing data with human reviewers, especially if they are third-party vendors. And then finally, when it comes to validation, customers want to be able to securely onboard their human review workforce, set up rules for how and when humans get looped in to review output from automation based on business rules and other metadata such as confidence scores. Now that we have a deeper understanding of our customers' objectives and an appreciation for just some of the challenges they face, we will now segue into how AWS can help address customers' end-to-end IDP needs, beginning with data capture. Fundamentally, customers want to be able to securely capture and consolidate data in a repository with bespoke compliance and governance rules, keeping in mind that the data could be coming from anywhere, including physical or digital mailrooms, as photographs or scans from end users, or even as email attachments. This is where we see Amazon S3 is a very popular choice with customers as a proven, cost-effective, scalable, secure, and highly resilient solution for enterprise document storage, as well as archiving. Moreover, we see that the data may be captured in a variety of different formats depending on the source. And for this reason, our services support a variety of scanned document types, such as PDF, JPEG, PNG, or TIFF, in addition to digital text in Word, TXT, and other digital native file formats, of course. In addition, particularly for scanned documents, we realize that customers often do not have control over scanning quality, and therefore our services autocorrect for all kinds of scanning defects ranging from distortions, rotated text due to scanning misalignment, noise created by dirt or smudges, automatically without any customer or end user intervention. Now let's talk about document classification. So as mentioned, a single loan package can contain a wide variety of documents such as asset income statements, employer pay stubs, the 1003 loan application, the 1040 tax return, home appraisals, titles, and many, many more types of documents. In order to ensure that the correct routing and business rules get applied, it is imperative that first and foremost, customers get very high accuracy on classification of these documents, as even small errors here can get magnified in the context of the overall document processing pipeline due to misrouting or application of wrong business rules. At the same time, customers want to be able to customize the classification based on their business needs without having to train an ML model from scratch. And they can achieve both these objectives of flexibility and high accuracy using a combination of Amazon Textract and Amazon Comprehend services as shown here. Now let's talk about extraction, which is at the core of any IDP pipeline. Starting with the left-hand side, we already provide industry-leading printed and handwritten text support for OCR for basic extraction of text from documents. While this is a good start, customers want to be able to extract data, not just the text, which means identifying and capturing relationships between text elements. For instance, automatically detecting key value pairs, information and checkboxes on forms, being able to extract row level, column level, or cell level information from tables. In addition, we offer purpose-built extraction capabilities for certain types of common documents, such as invoices and receipts for invoicing and accounts payable use cases, as well as identity documents for KYC, identity verification, and other types of use cases based on customer demand. And just last month, we launched the new Textract Queries feature, which allows you to ask natural language questions to extract specific pieces of information. To put this into action, let's take a look at how some of these extraction capabilities apply to real-world documents that are found inside a loan mortgage jacket after the classification step. For example, let's pretend that the first form that the IDP classifier identified is a Form 1040, as shown on the left-hand side. Since this is a dense form, I'm only showing the top half to make it easy for our viewers to follow along. As you can see, this is a standard 1040 US individual income tax return form that is required as part of most mortgage applications in the US. And this form is tedious to process because it contains hundreds of data points that are captured on this document in the form of checkboxes, key value pairs, tables, and more. And again, these could be printed or handwritten or a combination. Using the TextRack Forms product, extracting this information is as easy as a simple API call without having to train any ML models to create a digitized representation of this output, as is shown on the right-hand side. If you look at this output more closely, you will see that we were able to correctly capture the individual checkboxes associated with the filing status, whether or not they were selected. So for example, whether the filing status was single or married filing jointly. We were also able to capture relationships between field names, such as the primary taxpayer's first name, last name, their spouse's identity information, as well as additional details such as home address details. We were also able to detect the presence of additional key names such as foreign country name and foreign postal code and accurately represent the fact that these are blank. So now that we've extracted these key pieces of information from a 1040, it's also easy to see how not only humans could easily review this data, but how this information could be used to easily populate a database, for example, once it's digitized. As we continue scrolling down the 1040, we will see that the midsection of the same form actually has a table that is used to capture dependent information. Using the TextRack Tables product, customers can easily extract entire tables within documents while retaining the data integrity and relationships between text, which in this case would be information at the dependent level, including their SSN, relationship to the primary taxpayers, as well as checkbox information, which indicates whether or not they qualify for child tax credits or some other types of tax credits. So the tables product is able to automatically group cells within tables, including support for merge cells if selected, as well as words within each cell. And then all our APIs output confidence scores, geometry information, as well as row column indices, which can be used to easily traverse and navigate the extracted table structure. Thus, as you can see, using our forms and tables products, it's easy for customers to extract complex pieces of data that would be very difficult to automate using legacy OCR, at least with a high level of accuracy. Now let's take a look at a different type of a document that is also found in a loan application. And this could be a driver's license or a passport scan as proof of the applicant's identities. The challenge with extracting information from these type of ID documents is that if you look at the driver's license example, each state can actually have a different layout. And further, there's a lot of implied information on the document. For example, while you can accurately infer that the value Souza is associated with the key labeled 1, you cannot actually conclude that that is the person's last name. Similarly, while you can extract the different date entities on the card, you would have to write additional logic to figure out which was the issue date, the date of birth, and expiration date, knowing that there can be variations in how these values are presented on the document. With TextRack's Analyze ID product, you can easily extract all the relevant pieces of information from US driver's licenses and passports without having to build any custom templates or configuration of your own. More importantly, the API is intelligent enough to automatically normalize key names into standardized fields that are pre-populated in the response, and it's also able to map implied elements such as names, addresses, and more. Another common document type that is found in loan jackets are pay stubs. Extracting information from pay stubs has historically been very difficult to automate, at least with a high degree of accuracy, because there is no preset layout or format, and the information itself can be presented as a key value pair within a table or both. However, what customers want to be able to do is simply extract key pieces of information from the pay stub, such as what is the applicant's year-to-date gross pay, what is their federal income tax, or whether even the applicant's name on the loan application matches the name on the pay stub. Instead of first extracting all these pieces of information through OCR or tables and forms, using the latest TextRack Queries feature, customers can now simply pose natural language questions as an input to the API to extract specific information of interest from documents, and they receive the data points in form of question-answer pairs, which is easier to process. Behind the scenes, we're applying best-of-breed computer vision and natural language processing techniques to study the visual, spatial, and semantic content of the document to return the most accurate response which has the benefit of achieving very high levels of accuracy out of the box on just about any type of document. Again, no training necessary on behalf of customers. Another powerful example of the queries product is its application for W-2 forms, where lenders may want to extract all types of information, such as wages, tips, and other compensation, which is popularly referred to as Box 1 information. In addition, they may want to know what is the employee's SSN, and they can pose a natural language question that says, what is the employee SSN? And TextRack will automatically determine the right value, which is the 333224444. Note that the actual representation of this value on the document is different in that the social security number key is fully spelled out, while our query has this intent abbreviated. But as I mentioned, because TextRack queries can automatically normalize and reconcile key values, so customers don't have to worry about these variations. Similarly, TextRack can extract the employee name and employee address information, even though they're clubbed in a single key under Section E, which again reduces the amount of post-processing that customers have to write. With that, we conclude the extraction portion of the IDP pipeline. And as you can see, AWS offers a wide variety of extraction options. However, once you've extracted these pieces of information, you may realize that you want to perform supplemental post-processing or enrichment of this data prior to invoking the human review step. In this scenario, let's suppose that we have a hypothetical applicant, John Doe, and due to a business rule such as the income to debt ratio of this applicant being lower than a predefined business rule, this applicant is flagged for human review. Using Amazon Comprehend, it's easy to identify a number of pre-trained PII entities, such as name, social security number, date, credit card numbers, email, phone, age, and more, as well as the fact you can train a custom entity model to identify additional entities, such as policy ID. So with Comprehend, it's easy to get a copy of the text where it not only detects the pre-trained PII entities such as name, SSN, and date, but in this case, it automatically does the redaction, while you can write custom redaction rules so that only a portion of the policy ID is redacted in case that's what the customer chooses. Last, I want to talk about validation, and it is worth pointing out that AWS IDP does not always have to necessarily replace the human altogether. Instead, it's about how IDP can dramatically improve the efficiency of human reviewers and free up their time to focus on higher value tasks such as risk analysis and making high quality loan decisions instead of spending anywhere from 30 to 50% of their time in data gathering and entry. Using our IDP services, you can focus on maximizing the fraction of straight-through documents that are automatically classified, extracted, enriched, and uploaded to business systems for decision-making, while only bringing humans into the loop when absolutely necessary. For example, this could be when the confidence scores of extraction are less than a predefined threshold that your business is comfortable with, or it could be if a particular key is detected, such as the net income from a pay stub, or let's say if it's missing altogether. Ultimately, the goal is that all of this can help reduce the overall cost of document processing while helping you boost top line or customer satisfaction as well by allowing your finite, precious human review workforce to scale more efficiently and serve end customers faster. To tie this all together, I would like to share a quick customer anecdote of how customers in the mortgage lending space are already taking advantage of AWS IDP services to improve process productivity. One such customer is Black Knight, which is a leading player in the US mortgage industry that offers high performance software data and analytics for mortgage and home equity lending and servicing. Black Knight was looking to improve its overall process efficiency, and it quickly realized that there were several inefficiencies in the loan review process, which slowed down human reviewers, which could be incomplete loan packages, missing data, ad hoc discovery of additional documentation requirements. And so to address these inefficiencies, Black Knight turned to automation and decided to harness AI-powered AWS IDP services such as Amazon TextRack to extract information automatically from multiple sources of income, asset, property appraisals, and an ever-expanding assortment of documents to accelerate digital transformation and reduce their underwriting risk. As a result of this investment, AWS IDP services such as TextRack has helped lenders increase their operational efficiency, reduce human review time by as much as 50% in some cases, and help serve end customers faster. With that, I would now like to walk you through a visual demo for the lending IDP example. And as I'm pulling this up, the purpose of this demo is to highlight how customers can easily build an end-to-end document processing pipeline using AWS IDP services for different tasks within the overall workflow, starting from data capture to decision making. Now, as you can see, we have mocked up a loan processing portal representing the outcome of different loan applications that have historically been processed, as well as those requiring further review from an underwriter. As you can see, one loan application has already been approved. One has been rejected because of missing documentation. However, I now see that a new application was recently added to my underwriter's review queue. So I'm going to go ahead and open this application. So the first thing that I see when I open this loan is that there are 7 different documents that have been uploaded as part of this new application. Note that at this stage, I don't know what type of documents are these. All I can tell is that there's a combination of different PNG and then PDF files. So the next thing I'm going to do is actually identify what's what. So I'm going to go ahead and click the next button so that I can enter the document classification stage. Now that I'm in the document classification tab, I can see that the portal was able to leverage the power of Amazon TextRack and Amazon Comprehend to automatically classify the different documents that were uploaded using a custom classifier that was trained previously. Looking at the status tab, it appears that most of the documents were successfully classified, and I can go ahead and spot check some of these documents to make sure that this classification was indeed accurate. So I will click on the form that has been identified as the loan application form and verify that it is indeed what we call the URLA or the form 1003. Similarly, I can verify that the passport document that has been uploaded here is an actual passport scan. So I can leave the classification as is. The one document type that the system has flagged for my attention is the bank statement. And so I'm going to see, if this is actually true because it's actually asking for me to step in. So as I pull up the document, I can verify that this surely does look like a bank statement. So I'm going to leave the classification as is. Though if this was different, I could have obviously chosen to manually override this decision if I so chose to be appropriate. So with that, we'll proceed to extraction. So the first form that we see is the URLA, or the primary loan application form. And I can quickly see that the purchase field was selected, indicating this is a home purchase versus a refinance. I can also quickly see the loan amount that is being requested, which is the $450,000, as well as the fact that this is a fixed rate loan, since the appropriate checkbox information was captured. As I scroll down, you can see that using the TextRack Forms product, I've been able to quickly extract all key pieces of information without having to train any bespoke machine learning models of my own. All of that AI-powered intelligence is already integrated into the portal through simple API calls. Now, as you recall, URLA is just one of several documents that can be present. So I'm going to go ahead and pick a different example here. Let's say the W-2. Once again, you can see that all of the key value pair information has already been extracted using the same TextRack Forms product. And now I can get additional information about this applicant's application, such as federal income tax withheld, what are their social security wages, etc. Next, we will open the bank statement. And as you can see, TextRack Tables is able to extract the account summary information containing information about their checking and savings account, including their account number and balances. It's also able to, by the way, detect multiple tables within the document. So I have a second table which has not just the prior balance, as well as the list of transactions spanning debits and credits that I can use to arrive at the new balance, which then I can use for post-processing. For instance, if I need to source any foreign income that the applicant may have acquired as part of this step. Finally, let's continue with our IDP journey, and let's take a look at another statement that was uploaded, which is the Homeowners Association, or the HOA statement. As you can see, this document is not as tightly structured as some of the other documents we've seen so far. Yet we know that every HOA statement needs to reflect, the dues, property address, transfer fees. So this is where the TextRack queries feature that I talked about can be really powerful. For example, without even worrying about how different HOA statements may be structured, I can simply pose queries such as what is the address of the property, and get the answer, as you can see here. I can even pose a query saying what is the total dues to be paid, and TextRack currently identifies that that amount is $315.58. Similarly, I can even ask queries that answer information such as, what is the closing date and more. So now that we've extracted all of this information, from many different documents, let's say we want to get an extra pair of eyes out of abundance of caution on pay stub to make sure the information is accurate and the numbers tick and tie. But however, due to compliance regulations, we're required to redact PII information before we send. So redaction is as simple as the click of a button, where the first step is you'll see that these PII identities are automatically detected by Comprehend. And then by clicking this option, I can easily redact the extracted information and also create logic that, redacts the information on the documents itself. Last but not least, I want to show you what the review and verification stage of the process could look like before I send it for additional post-processing. So as you can see, I've implemented checks for certain types of documents, such as, making sure that the 1003, the W-2 pay stubs are actually part of a loan jacket. And if a document was missing, it would flag here and not let me proceed. Similarly, I can add all kinds of business rules, as you can see here, which is around, different fields being extracted with a confidence threshold that's higher than, let's say, 85%. I could even create custom business rules, such as making sure that the ID name on the passport matches what's in the loan application before I, forward the information to the downstream loan processing system. So with that concludes the mortgage use case deep dive portion of the presentation, and I will now turn it over to my colleague Sonali, who will walk us through a different IDP example, this one for insurance.
Thank you, Rahul, for taking us through the IDP overview, or Intelligent Document Processing overview. As mentioned before, IDP can apply to use cases across industry. So let's look into one such use case on the claims processing or the claims adjudication process in insurance industry. Before diving deep, let's bit about claims processing. So claim processing consists of various stages where insurance companies follow a series of procedures to check the claim request for the required information, validation, justification, and authenticity to determine the accurate financial responsibility. So now quickly look into how this claims processing would look like with our intelligent document processing pipeline. I often get asked about how AWS thinks about intelligent document processing. And while it seems simple, it is a complex problem to solve. Each document or use case may require different process, which is why AWS has services to help you in each stages of your IDP pipeline. The diagram in this slide is a high-level design of possible stages, such as your data capture stage, the classification stage, the extraction, enrichment, and finally the review and verification step of IDP pipeline, where customer go through to build an end-to-end solution. And as mentioned before in the mortgage industry use cases, we will take you through how each stage will apply to claims processing use case. This is an example of IDP flow where the goal is to reduce the amount of time, reduce the cost, as well as deliver the better customer experience at the same time. Moving on to the first stage, that's the data capture stage. That is where you aggregate, store all your documents in a reliable, durable, scalable, secure data storage, such as Amazon S3. And data can come in various different formats and channels. It can be structured, unstructured, can be a dense paragraph of text type of document as well. And we need a mechanism to support this data diversity. And that is why we have Amazon S3 to store these documents in a scalable, highly available data store. For claims processing, we will take you through various different documents type. It can be of CMS 1500 form, it can be of CMS 1450 form, it can be of Accord form, it can be supported documents such as like ID documents or invoices, receipt type of documents. And we will show you those document types in a quick demonstration of claim processing as well. Moving on to the next stage, that is the document classification stage of IDP pipeline. At times, we get multiple documents of various different types and do not have any automated way to identify and classify those documents. For example, if you have claims form and an ID document in the same folder, you need to categorize them accurately for further processing as per your business logic. Moreover, figuring out like what types of documents are included in the claims document before even processing it can save a ton of time and effort. And that is why we have our AI service such as Amazon Comprehend to classify your documents accurately. I will not be diving deep into the extraction feature of Amazon Textract as Rahul has taken through these features in the previous IDP introduction. But what I will show you how to use Amazon Textract feature for the accurate extraction of data elements from a claim form. And here you can see it is a CMS 1500 form. Using Amazon Textract on the right hand side, you can see like we have accurately extracted all the key value pairs, such as like you can see the inserted ID number. At the same time, all the checkbox element can be extracted accurately. If it is a radio button, that also can be extracted accurately. Similarly, you can see a handwritten text in there. So Amazon Textract can extract both printed as well as handwritten text. At the very bottom of the slide, you can see we have a table type of information. So Amazon Textract can extract those structured elements from your any type of document. In this case, it's a claim form. Moving on. Now let's switch gear and see how we can handle a specialized document such as invoice or receipt type. As you are probably aware of, receipts and invoices are documents that are critical in the enterprises for managing their accounts payable process. These type of documents are difficult to process at scale. But using Amazon Textract Analyze Expense, customers can now not only extract line items detail, but also implied key value pairs from this invoices receipt, such as like you can see total, subtotal, tax, invoice number, that can be extracted accurately from any type of invoices or receipt document type. The more we speak to customer, we see a trend in there where customer wants to augment their document processing with additional inferred insights. Such as for healthcare claims, most of the time we have a need to process doctor notes, which is of type like raw, dense text type of document. Using Comprehend Medical, you can extract and infer medical condition, medication, test treatment procedure, in addition to medical ontology linking or the medical coding standards such as like ICD-10 CM code, RX norm code, and SNOMED city code. Moreover, in regulatory industry, there is always a need to redact the sensitive information. And you can very well can do it with a click of a button with the Comprehend PII or Comprehend Medical PHI detection to detect those elements and further redact those elements. And not the least, you can include human being for your review and verification of your document. Like in the IDP pipeline, as mentioned before, you can have human review as needed as per to meet your confidence threshold or your business requirement. Now let's see how one of our customer is using this intelligent document processing for their claims use case. And our customer is Anthem. Anthem was looking for a solution to reduce their manual labor and cost to automate their claims processing solution. And Anthem chose Amazon Textract to digitize their claims process by using Textract tables and a form type of API to automate the extraction process for the claims processing. At Anthem, it took an average of like 20 minutes per claim to manually extract this information. Now it is automated with the help of intelligent document processing. And this is a very high level architecture of how these AI services can fit into various different stages of IDP pipeline that we discussed just now. I will not be diving deep, but I will be giving you the link to the source code and the resources which you can leverage to automate your IDP pipeline. Now let's look into the cool feature and how IDP pipeline can apply to claims processing use case in an insurance demo. So now let's move on to the insurance industry demonstration. And this is the UI from a case worker perspective, but in real, the claims would be processed automatically at high volume. And one of the benefits of IDP is able to handle easy yes or no easy decision based on the customer's business rule. So now let's click on this case worker portal. And in the middle of the claims, you can see there is a claim which has been auto-rejected because not all the documents have been uploaded. And we will discuss about this in a little later of our quick demonstration. But for now, let's click on this new claim that has been filed. As you can see, this is the first stage of IDP pipeline, that is the document capture stage, where claims document can come in multiple different channels. It can be like mailroom emails or the portals. And the first step is to figure out what you have. Today, this process is mostly manual, but your IT team can help connect the sources of your documents to the IDP workflow. As you can see in the first document is a document 1, which is a not labeled type of document, but it is of type PDF as well. But if you open it, you can see this is a CMS 1500 form. Similarly, let me click on the next document, which is a document 6. Again, it is not labeled accurately, and it is like PNG or any scanned image type of document. And if I open it, you can see like, hey, it is an medical insurance invoice type of document. So without accurately knowing the labeling of the data, we have no way to categorize those unless we open. Can we automate this process? So the answer is yes. Using Amazon Comprehend Custom Classifier, we can automate this classification process. And you can see all these unlabeled documents are being now labeled accurately. There is a human being reviewed option is it's shown here. So there is an option to review this document and correct anything as per your business need. For example, you can open this document 5 and you can see this is an insurance ID. So I'm not going to change the recommended output of the ML model, but there is an option to change from this drop-down menu. Moving on to the extraction stage of intelligent document processing. And here you can see, looking at the CMS 1500 form, the AI is able to extract all the key value pairs. For example, total charge, it is like 405, that has been extracted accurately from this document type. We are not displaying it on the screen, but each field has also a confidence score which allows you to set up business rules that will determine when a human review is required or not. Now moving on to the insurance ID type of document. In this insurance card, you can see that all the key value pair in here has been extracted accurately. Moreover, if you need all the raw text, that also we can extract using Amazon Textract. ID document type. Amazon Textract can extract elements from ID type of documents such as US driver's license or US passport. And here we are using Textract's Analyze ID API to extract and normalize the fields from any type of ID document. And here we are using a driver's license document. Similar to our ID document type, as discussed before, our AI also has advanced capabilities to understand invoices and receipt. For example, you can see fields such as like subtotal of 2071 or the discount 1812 or the tax of 146 and total 405, which is helpful to make it cross-check the amount with the invoice and the claim form, whether they have accurately mentioned in the claim form or not. Moving on to the next stage, where many businesses need to find information that is unique to their use case within the dense paragraph of text, such as in this discharge summary. We are using Amazon Comprehend to extract insights from this discharge summary document, which is of unstructured paragraph of text. Amazon Comprehend can give you the pre-trained entities such as like a person, date, location, quantity, and many more. Also, we have a trained Comprehend custom entity recognizer. Here you can see to extract the patient name or admitted date, discharge date, as well as patient ID field from this paragraph of text. Comprehend custom NER model also returns a confidence score for each element that it detects. Quickly wanted to highlight that we can process documents of poor quality as well as if it has skew elements as well. One of the challenges in processing unstructured medical text like doctor notes in this sample here, or any clinical trial reports or radiology reports, is finding enough qualified staff or the medical professional to extract the medical information. But our health AI can identify this relationship among extracted health information and can link to medical ontologies, such as here ICD-10 code, as in this example on the right-hand side. At the same time, Comprehend Medical also can give you the RX norm code as well as the SNOMED city code. As in the mortgage processing loan application processing demonstration, we can use PII redaction feature with Amazon Comprehend to redact any sensitive information from our document. Now that we have all of the information from the documents, let's see if this claim meets the business requirement before moving the information to the claims decision system. The first section at the very top shows that there are no missing documents, and that's one of the reason one of our claim in the first screen of the demonstration was auto rejected, because not all the documents have been uploaded. In this section, the key field needed to process the claim meet the accuracy standard set by the business requirement. You can also cross-check your elements across documents. For example, in this document or the cross-validation rule, you can check like whether the total of the claim amount is consistent across various documents, such as like in the invoice that matches with your claim form, such as the CMS 1500 form or not. At the very bottom, we have an option to specify rules for medical coding level validation as well. Now that the claim has been through the IDP process, it is decision ready. This could be as simple as auto approval for low dollar claims, or might be the information could be sent to the downstream application or human for a decision review. So this is a quick demonstration on our insurance claims processing use case. Moving on, if you want to do the same and want to implement the same for your IDP use cases, we have resources for you to get started out with. We have a 3-hour IDP workshop, as well as it has hands-on code and all the GitHub resources and link for you to easily get started out with. At the same time, we have reference architecture for you to follow through this blog post as well. If you want to implement and talk to our IDP specialist, I highly recommend you to reach out to your AWS account team to speak with our IDP specialist. And at the very end, I hope this session is useful for you. And thank you very much for attending this session. Thank you.